Hello students, in this video we are going to understand the various operation of discrete time signals. In the previous video we have understood the concept of discrete time signal. If you have a continuous time signal, with the help of sampling theorem you can convert your continuous time signal into its corresponding discrete time signal. That means the signal will give various amplitudes or various samples, or you can say various samples of different amplitudes on various instances of different instances of time. So to understand the various operation, I have taken two signals x1t and x2t. x1t exists on the values -1, 0 and 1. At t is equal to -1, it is having amplitude 1. At t is equal to 0, it is having amplitude 2, and it is having amplitude 3 at t is equal to 1. Similarly, x2t exists at -2, -1 and 0 with the amplitude 1, 2 and 3. So now on the basis of these two signals we will perform various operation. First we will see addition. So x1t plus x2t, that means we are adding both the signals. So addition can be x1t plus x2t or x2t plus x1t, both will be giving the same result. So x1t plus x2t will give the result as 1353. I am giving the result in the curly brackets, and I have kept an arrow below this value 5. So this arrow always indicates the zeroth sample. Zeroth sample means it is giving or denoting the value at t is equal to 0. So when you add these two samples, here at t is equal to -2, it is value giving as 0, and at t is equal to 0, here the value is 1. So 0 plus 1 will be 1. Then -1 giving the amplitude as 1. Here -1 is giving the amplitude as 2. So 1 plus 2 is 3. Then at t is equal to 0, amplitude 2, t is equal to 0, amplitude 3. So 3 plus 2 is 5. And then at t is equal to 1, amplitude is 3, and t is equal to 1, here amplitude is 0. So the addition of 3 plus 0 is 3. So graphically also I have drawn the diagram. It is 1, 3, 5 and 3. So this is how addition is performed. Now we will see the subtraction. So subtraction means either I can subtract x1t from x2t and x2t from x1t. So both I have shown. First we will see x1t minus x2t. That means x2t subtracted from x1t. So it will be giving -2 is having value 0. Here -2 is value 1. So 0 minus 1 will be -1. Then 1 minus 2 is -1. Then 2 minus 3 is again -1, and 3 minus 0 is 3. So basically how I am subtracting? I am subtracting the corresponding samples. So accordingly I am getting the result as -1, -1, -1 and 3. Again this arrow indicates the 0th sample. So this is -1, -1, -1 and 3. Now I am reversing the operation, that is x2t minus x1t. So now I am subtracting x1t from x2t. So at -2 it is having value 1, at -2 it is having value 0. So 1 minus 0 will be 1. Then at -1 it is having value 2, and it is having value 1. So 2 minus 1 will be 1. And then 0, 3, and here 0 is 2. So 3 minus 2 will be 1. And then at t is equal to 1, here x2t is having value 0 and x1t is having value 3. So 0 minus 3 will be -3. So graphically it is 1, 1, 1 and -3. So this is -3, this is 1, 1 and 1. So this is how mathematically and graphically I have represented addition and subtraction of two signals x1t and x2t. So I hope you understand the concept of addition and subtraction of two signals. Now we will see the multiplication. So x1t into x2t. So corresponding samples will be multiplied, So at t is equal to minus 2, here the sample is 1, here the sample is 0. So 1 into 0 is what? 0. So at t is equal to minus 2, the value is 0. Then at t is equal to minus 1, sample is 2. T is equal to minus 1, sample is 1. So 2 into 1 is 2. So at t is equal to minus 1, value is 2. Then at t is equal to 0, here sample is 2, here sample is 3. 2 into 3 is 6. And then at t is equal to 1, here value is 3, here value is 0. 3 into 0 would be 0. So this is how multiplication will be performed. So the general operations are addition, subtraction and multiplication. Other than that, there are two more operations. One is known as shifting operation, another is known as folding operation. Shifting means you are shifting your signal either in the negative direction or in the positive direction. So first we will see xt minus 1. That means you are pushing your signal from left to right. T minus 1 means your signal is shifted with one sample towards the right direction. That means in this direction. So the sample which exists at t is equal to minus 1 now will be existing at t is equal to 1 as it is shifted from left to right by one sample. So at t is equal to 0, it will be giving the value as 1. At t is equal to 1, it will be giving the value as 2, and at t is equal to 2, it will be giving the value as 3 if you are shifting your signal in the left to right. Then another is x1 of t plus 2. That means you are shifting your signal from right to left. Basically, x of t minus k. Here, if k is positive, you have to shift in this direction, and if k is negative, then you have to shift your function from, you can say, left to right and then right to left. This is how you have to perform. Here x1 of t plus 2 is basically x1 of t minus of minus 2. Basically this is like this. That means the value of k is negative, but it is the way of writing that I am writing it as x1 of t plus 2, but basically it is x1 of t minus of minus 2. That means this value, which is a number, is a negative number. So that is why we are shifting the function or the signal from right to left. So right to left by how much sample? 2 samples. So the sample which existed at minus 1 now will be existing at t is equal to minus 3. 0 will be existing at minus 2 and 1 will be existing at minus 1. The values will remain same, which is 1, 2 and 3. So this is the shifting operation from left to right and right to left. Left to right means k is positive, right to left means k is negative. This thing you must keep in your mind because this operation will be there throughout the subject. Finally, folding. Folding means you are folding, that means you are changing the positions of all the samples from negative side to positive side. That means the samples which are existing at the negative side will come to the positive side, and all the samples which are existing at positive side, they will move to the negative side, and the sample which remains intact or as it is will be the sample at t is equal to 0. It will not move. So if I want to see the folding effect on the function on the signal x1t, I will write it as x1 of minus t. So the sample at t is equal to 0 will remain same. That means it is giving the value as 2. The sample of minus 1 will be now at t is equal to 1. So at t is equal to minus 1, the sample was 1. So now this sample 1 will come at t is equal to 1. And the sample at t is equal to 1 will be there at t is equal to minus 1. So at t is equal to minus 1 it is 3, t is equal to 1 it is 1, and at t is equal to 0 it will remain as it is, which is 2. So this is what the folding operation. You are just giving the mirror image of your signal. So this is shifting and folding operation, multiplication, subtraction and addition. So these are the various operations on discrete time signals. Now on the basis of this we will solve few numericals and few questions. So then all these things will be easily understood to you by few examples which we will cover in the next video. I hope you understand the concept. Thank you for watching.